Just so that you all know, so exoplanets, of course, are planets that orbit stars far beyond our own sun. They're parts of solar systems beyond our own. We just saw in the piece that we saw on screen that there are this vast number, more than 4,000 exoplanets that are known now. We've entered a new age of discovery, and we're all part of it. And I'd like to start, though, by going back a little bit, back to the 1960s, and we'll see if you... Does anyone know who this is? Okay, oh, well, there it is. Mr. Spock from Star Trek. The actor Leonard Nimoy actually grew up here in Boston, but the character that he plays, Mr. Spock, grew up on, which planet was that? Vulcan, the planet Vulcan. Now, of course, Spock and the planet Vulcan are science fiction, but in the series, the planet Vulcan was said to orbit this star, which is in fact a real star. It's, well, it's one of those right in the arc there. Doesn't matter because they all look the same. But, so how could the producers get away with that? There's no planet Vulcan there. But in the 1960s, and for the next 30 years of reruns, no one on Earth had any idea whether there were planets orbiting any other stars in the universe. Only in the last few years do we realize that there are so many exoplanets. And in fact, last year, astronomers discovered that there really is a planet Vulcan orbiting that star. It's a little bit too close to its sun, to its star for there to be a Mr. Spock. It's probably too hot, although maybe that's why they call it Vulcan. But you never know, right? You never know. So, and this picture is courtesy of NASA. It's the artist's view of what that planet might look like. So we've seen 4,000 exoplanets popping up there. And most of these are due to the NASA spacecraft Kepler, which has been in space for many years, and now a new one, TESS, has been launched. And it's looking specifically for Earth-sized planets that are nearby and where we might have a hope of studying them. Here's from the early Kepler series. Here's let's see here. Okay. Well, I guess this is not wanting to, well, okay, well, we don't need them to be spinning around, but here's then a static picture of many of the solar systems that have been discovered. I think you can make out our own solar system in there. Our planets move at a stately pace compared to all the others, which kind of whiz around, because it's easier to find planets when they're close to their stars. And the closer you are to your star, the faster you whiz around and orbit. That's because gravity is stronger there. Now they're moving. Well, okay. The amazing thing is that from those 4,000 stars, 4,000 planets that have been discovered, we can extrapolate to the rest of our galaxy, because we have a good statistical sample. And we find that there are essentially exoplanets orbiting, on average, every star in the night sky. So when you look up at the night sky, virtually every star there will be a solar system. And we know that for planets that orbit small stars, which are the majority of all stars in our galaxy, most stars are smaller than our own sun. For those stars, 1 in 6 of them will have an Earth-sized planet that's in the habitable zone of its star. That means that in our galaxy, there are well over 1 billion Earth-sized planets, 1 billion other potential Earths. And I just want to show you, I mean, what that might look like. So here's a Hubble telescope picture, not of our own galaxy. It's looking at the next one out there, the Andromeda galaxy. because we get a good view of all the stars compressed. And now I'm going to zoom out. There are a lot of planets, okay? Now, I'm not going to say very much, I'm not going to say anything about how you detect these planets and study them, because you can actually do it yourself using resources that are online. So when you go home, you can just Google Exolab, E-X-O-L-A-B, and you'll see the laboratory for exoplanets at the Center for Astrophysics. That's meant for people in junior high school and high school. But you can easily do it yourself at home, and you'll have access to all the resources, including online telescopes, so you can take images of these solar systems yourself. Now, why should we care about these worlds? They are so far away that we're not going to travel there on vacation. We'd be dead before we got a tenth of the. We'd be dead before we got off the ground. No, why do we care? We're not going there on vacation, and we haven't gotten any calls from anybody out there, so it's not as though we're being invited. And if you were looking for a pen pal, you wouldn't pick exoplanets, because even the nearest exoplanet is so far away, 4 light years away, that it would take 4 years for a message to get there and another 4 to get back. Most of the planets we'll talk about are, say, 50 light years out. So that's a conversation that's generational. You won't get the answer, but maybe your grandchildren will get an answer back. And there's something very attractive about that. In Switzerland, they have a festival that takes place every 25 years. And I thought that was really nice, because it means that each festival is sort of owned by the next generation. But that's what it will be if we have conversations with any life forms that are out there. Unless, of course, they have subspace communication, as in Star Trek. That's a different matter. Now, seriously, for me, one of the real reasons we care about exoplanets, given that we're not going there, is that they can tell us so much about who we are. Where did we come from? Why are we on this planet? Where did the planet come from? Where are we going? How do we stack up against the other communities and planets out there in the galaxy? So our solar system is not typical, and we're finding a whole variety of worlds that don't look anything like the planets in our own solar system. There are dark worlds, darker than anything known, darker than coal. We don't know why this particular planet, TRES-2, doesn't reflect light. There are water worlds. These are oceans with no land, and so not a place to go if you get seasick. But no one knows whether life can actually form in a water world without having land. On Earth, there's a delicate balance between the land and the seas, and that balance keeps the climate stable and promotes the stability of life. And there are people studying what happens when you have an ocean that's not just a few thousand feet or a few miles deep, but is actually much, much deeper than that and goes all the way down. And then there are worlds that have an ocean, but it's molten rock. These are magma worlds. Let's not go there, okay? We won't. And then there's one, I find this fascinating. It's a planet in which it's so hot that it rains glass at high altitude and rains titanium at lower altitudes. And here you see an artist's conception of that. But again, let's not go there. Now, one of the, well, you've seen this. This is from Star Wars. This is the planet Tatooine, which has 2 suns, 2 sunsets every day. And astronomers used to think that that couldn't happen, that when you have 2 stars orbiting each other, somehow the gravity is complicated enough that you're not going to also form planets. We now know that's not true. Nature likes planets, and it seems to be producing them in profusion. In fact, just recently, a planet was discovered with 3 suns in the sky. That's It's sort of nice, I guess, for the 18 days in its orbit, because then you get to see 3 sunsets a day. But then for the other 18 days of its orbit, 2 suns are on one side and the other sun is on the other side. And so there's no night. There's always a sun in the sky, so you can't get any sleep there. So we won't go there either. Most of the stars in our galaxy are actually binary stars. They come as pairs or as triplets. And in fact, Mr. Spock's star, the one that really exists there and where we found the Vulcan, that's actually part of a triple star system as well. So these scenes will be common. Here's a solar system that scientists are really excited about. It's called Trappist I, because the scientists in Europe who discovered this system celebrated by drinking a beer that was made by Trappist monks. And that just shows there are so many stars, so many worlds out there that a little levity is called for when you're naming these things. You don't want to just give them numbers. There are 7 Earth-sized planets in this solar system. And many, if not all of them, are actually in the habitable zone. This drawing is not to scale, but the planets are all within the orbit of Mercury, very close to their star. And they're temperate because the star is much smaller and cooler than our own sun. So those planets are sort of squashed in, huddling around this star as they go in orbit. And if you were on one of these planets, you'd see the other planets in the solar system looming huge. They'd be much larger than the moon is in our sky. So it would be quite a spectacular view. And in fact, NASA, I think, made this poster of a trip to Trappist I. I don't know if you can read it. It says, planet hop from Trappist 1E, that's the planet E out there, voted best Hab zone vacation within 40 light years of Earth. Now you'll notice that the planets are all red here, and that's because the star itself is very red. It's a little bit like, if you lived there, it would be like spending the rest of your life next to a campfire, which has its moments, but it's not something you'd want to do forever. No one actually knows whether you can have life in these planets that are very close to small stars. We're hoping that you can have life because there are so many of these stars and there are so many Earth-sized planets. But the problem is that these small reddish stars are, even though they live a long time, when they're very young, they're temperamental. And they give out all these violent bursts of solar flares, just the way our own sun does, but we're far enough away and we have a magnetic field, so it doesn't bother us. And so there's a lot of concern that these planets might lose their atmosphere before they even get a chance to have life. But we don't know, and that's why people are so excited in studying them. Now, I'm just taking the liberty because we're looking at artists' conceptions, and we're not going to see photographs of exoplanets because they're so far away. I just wanted to remind you that the diversity of exoplanets begins at home. And so I just wanted to show you some images from our own solar system. Let's see if you can guess whether any of these are, what planet are these from? Any ideas? Yeah, here, dust devils on the sands of Mars. Yes, exactly. And this is the South Pole, actually the North Pole of Mars, and it looks like ice, but it's not. It's dry ice, which is, with that frozen carbon dioxide. It's the stuff you get at the bakers. And I'm going to keep going here just so that we see our other planets. This is familiar, I'm sure. And there's the red spot, there's Jupiter. And of course, this one is hard to conceal, right? We know what this is. This is Saturn, exactly. And that moon is Titan, which has lakes and mountains, and it rains there too, but it rains methane, which is not something that we... Now, I think one of the most exciting things about exoplanets is that we get to see the future and the past of Earth if we can actually find and study all of these Earths that are out there. In fact, we can see planetary formation from cradle to grave. So this is an image, a recent image, of a solar system in the process of formation. There aren't even any planets here yet. The sun is actually very tiny, and it's in the center of this disk. And then you see those black rings. That's presumably where planets are forming, or large pre-planets may be forming and sweeping out the dust and gas that we're seeing here. Here's something that was just published 2 days ago, very exciting. Here's a twin baby solar systems. These are two planets that are two stars orbiting each other, and that pretzel of dust and gas will become a solar system. It is, isn't it? It really is. And speaking of cool, here's something that's really cold. We'll see Earth when it was very young, and we'll see Earths that went through the same stage we went through, snowball Earth, because our sun was much cooler when it was young. And so the Earth would have frozen solid. We would not be here today were it not for volcanoes and other Earth processes that kept things warm. We'll see prehistoric Earths. We'll see Earth before there was enough oxygen for us to survive, and we'll see Earth when there was too much oxygen. We'll see Earths where there's 40% oxygen, as there was back in prehistoric times. We can only breathe 20%, which is what's in the atmosphere now. And then, perhaps most exciting, is that we'll see what happens. Do we find life on planets that are physically like Earth? We can't replay evolution here on Earth, but we can see it being replayed on all these copies of Earth that are out there. And then perhaps it's the most interesting and I think distressing, so I won't dwell on it, is we'll see what happens to Earths in the future. What happens to planets that have had a lot of life? Life has flourished and then suddenly it vanishes. Do we find that there are planets that are much older than ours? And so I want to say something about the challenge of exploring exoplanets. Why is it so difficult? And I can illustrate that with a picture of you. I actually have a picture of you I happen to have in here. I'm going to put it up on the screen here. Okay. Can you see yourself here? Oh, I didn't say it was a good picture of you. It's just, so way off to the left, you see a dot sort of to the left of the last bright ring of Saturn. Okay. That's Earth. So that's a picture of you and your friends and relatives and your pets and every living thing on Earth. And it's just a dot. So how would anyone know that there was life on that planet? Even if you had a big telescope here at Saturn, you'd see maybe a little tiny marble and you still couldn't see the life forms on the planet. Now, the nearest exoplanets are 1 million times farther away than Earth is in this picture. 1 million times farther away, and therefore 1 trillion times fainter, and they're 1 million times closer to their star, and so they'd be lost in the glare of their star. So, question is, how do we go from a dot to a portrait of an entire world? And we'll find out in the next segment. Thank you.